Hey, good morning, pre-algebra. So as we begin a new day, we get a new joke. What did the big bucket say to the little bucket? You're looking a little pale. That's right. All right, we're continuing our concept of exponents, and we're going to start out by looking at what do we do when we have an exponent of an exponent. So here is our example. I'm on page 515, so please follow along. This video should be fairly quick, and again, it may even be a review, although I think you'll see some new things. But don't go too fast. That's right, don't go too fast because you might miss something important. Alright, so what do we do when we have an exponent of an exponent? 9 to the power of 6 squared. Well, all we do, quite plain and simple, is we multiply them. Whenever we have the exponent, we have an exponent of an exponent, or giving us a term, kind of this term here, our base number with an exponent that is being squared, we multiply the exponents. So we'll end up with 9 to the power of 12. And we can leave it as that, unless they say to actually solve. But I doubt that because that's a really big number, and I don't think they want you to spend your time writing it down on a piece of paper. Okay, so just a few examples. What if we had n to the power of 4 to the power of 4? So even though we have a variable, we treat it the same. We'd still end up with 4 times 4, n to the power of 16. Alright, now here's a tricky one. Look at example 1c. We have 2 to the power of 3 to the power of negative 2. Now what do you think is going to happen here? Here we're dealing with a negative exponent. Well, since it is an exponent of an exponent, we're still multiplying, and we treat it just like a normal multiplication problem. Whenever we have one negative times a positive, the answer will always be negative. And the same rule applies. We're going to end up with 2 to the negative 6th power, or remember you can write it as 2, excuse me. If you want to write it with a positive exponent, you do 1 over 2 to the power of 6. Okay? So pretty plain and simple, that's our first step, multiplying. When we have an exponent of an exponent, we multiply them. Alright, turn the page. Now, what happens if we're dealing with a couple different terms? So here's the example. We are given, I'm looking at example 2a, 5r to the power of 7 squared. Okay? Now, we want to treat this, we kind of want to break it down. Not only is our squared going to be multiplied with our exponent here, but we also have this 5 to deal with. So when I break it down, we're really going to be doing 5 squared times r to the 7th power squared. So we're going to end up with 25r to the 14th power. So make sure that you distribute. Again, kind of like if you had 2 times 4 plus 5, you're distributing the 2 to both numbers. It's very similar with our exponent here. You're distributing the exponent to both numbers. Make sure that you follow all the way through. Okay, let's look at example B. We have 2x to the power of 6, I think. Yeah. Y cubed, and this is all to the power of 4. So I'm going to break it down for you. Again, you may not need to do this. You could do this quickly, but please, start out. We're doing 2 to the 4th power times x to the 6th power to the 4th power times y to the 3rd to the 4th. So 2 times 2 times 2 times 2 is 16. And then we have x, 6 times 4 is 24. And then y, 3 times 4 is 12. And that would be our final answer. Okay, one more example. We have negative 4s to the power of, I lost it, 5, then t to the power of 7, and this is all to the power of 3. So here we see something a little different. We have a negative number. Now, remember when we have a negative, we're still multiplying that number as a negative. We're treating it as a negative. So it's negative 4 times negative 4 times negative 4. So we have 3, so that means our answer will be negative. So negative 4 times negative 4 would be positive 16. But if we multiply that again by negative 4, we would get negative 64. Yes. Negative 64. Then s to the power of 15, because we have 5 times 3, and then 3 times 7 would be t to the power of 21. Okay? I hope that you kind of get what I'm doing up here on the board. Again, if you have questions, please feel free to ask, but I'm just going to keep cruising on. And now we're looking at example number 3. So here it gives us a little bit more of a challenge to think about. We kind of have to create our equation based on information. So it's asking us, express the volume of the cube as a monomial. So when we're trying to find volume, you are finding the length times the width times the height. That's how we find volume. And since it's a cube, all of these numbers are the same. So we're really dealing with s cubed. Because remember, like the length of a square, all sides are the same, and a cube is a 3D square. So we're dealing with s3, but they're telling us that each side, they're saying that s equals 2xy to the 5th power. So we actually need to plug this in to our equation here. So we're going to get v equals 2xy to the 5th power, and this is all being cubed. Now again, we distribute everything, so we're going to have 8, which is 2 to the power of 3. Then we're going to have x, and that's going to be 1 times 3, so we have 3. And then we have y, which would be 15. And that, gentlemen, is our final answer. I always want to say ladies and gentlemen, but no, at least in the classroom, there aren't any ladies listening to this. Maybe elsewhere in the world. But again, pretty simple concept. We are multiplying our exponents. So whenever, again, when we're dealing with an exponent of an exponent, we multiply them together. Just remember to distribute your exponent to all of the possible places. So that is our monomial. This is an example of a monomial. Remember, it's one term, but everything's multiplied together. So we can still break it down, and we treat each variable individually when we have that exponent. Okay, work hard, and I will see you in real life.